My name is Hadi. I'm the organizer of the workshop for the Beijing Hub. The title of this workshop is about energy and carbon awareness in Edge Cloud Continuum. And we are going to have 4 presentations today. The first one is about the energy and carbon awareness. The second one will address economics behind sustainable tech development. And then we will have 2 PhD students presenting their work. One of them is working on mixture of specialized experts for heterogeneous personalized federated learning. And the last one would cover temporal fidelity enhancement for video action recognition. So without further ado, I'm going to start my presentation. Just a few clicks here and there. Okay, so the first part of presentation is about the energy and carbon awareness in Edge Cloud Continuum. So I'll start with a very simple question. We all use ChatGPT in some sort every now and then. And whenever we send a query to ChatGPT, what happens is that the query goes through huge infrastructure, data center, through network cables. They use electricity, the power grid, and this electricity comes from various sources, let's say coal, gas, or renewable green energy sources. And that single query for running on the ChatGPT may not be a very great deal in terms of energy consumption, but considering there are millions and millions of queries received by those data centers every minute or every day, that would add up, and it would be a huge impact in terms of the carbon footprint. So the key question here is we want to know how much actually each of those queries will approximately cost in terms of energy consumption. So just a quick pick, let's say, if I send a single query for the ChatGPT or any other generative AI, would it be less than a Google search, or it would be about the same, or 10 times more, or we don't know? Which one is your pick?
To see, I guess.
Yes, it approximately costs 10 times more than just a Google search. And to give you an idea how much that is, let's say you want to send a query to ChatGPT. It will cost 3 watt-hour. It varies depending on the query, of course. If you want to boil a kettle, it would consume 70 to 100 watt-hour, which means that if you send 20 queries to ChatGPT, it would be equivalent to boiling a kettle when you want to prepare some tea. And scrolling on Instagram, 5 minutes will approximately use 2 to 3 watt-hour, which is equivalent to just one single ChatGPT query. And of course, there are more energy-consuming tasks, like running a GPU for AI training that would spend thousands and thousands of watt-hours to train. It's just a hint that we need to take this energy consumption more seriously. A few more statistical data here. So for training ChatGPT-3, it took 34 days to train. For ChatGPT-4, it took 100 days. It depends on the versions, the early versions. And the training energy consumption are also shown here. It's like 1 million kilowatt-hour for ChatGPT-3 and 62 million kilowatt-hour for ChatGPT-4. And that is really huge. I mean, if you consider the energy cost of just training ChatGPT-4 was $8 million, just the cost of energy. Not the infrastructure, just the energy. And that is for training only. But then after the system is trained and then they become operational, of course, they receive a huge amount of queries every day. And this is the cost on the right-hand side. This is the cost of running those queries. And the costs are really huge. So each year, it consumes like $140 million as a cost of energy to run, just the energy to run those queries. So these numbers show that the AI is using a lot of energy. And then we need to rethink, okay, do we have this amount of energy? What is the environmental impact of consuming that amount of energy? And what should we do about it? There are also another part of it. So we say there are visible part of energy consumption that we all see. Let's say I'm running an application on my laptop, and of course it consumes some energy, and I can somehow measure it, how much it is consumed. But behind those apps, like everyday use of different apps, Netflix, WhatsApp, any app, behind those using apps, which is visible to us, there is an invisible part to it. And that invisible part comes with the energy consumed by the data center. The energy comes from fossil fuels, sometimes the networking, if it's a wireless networking, if it's wired to the core network, routers, undersea cables for electricity transition, or data transition. So that's also another part of invisible energy consumption of the tech that we are using. So roughly speaking, it looks that the digital world may seem to be clean, but actually it is powered by real electricity. And by real electricity, I mean it can come from gray or brown sources of energy, like coal, like fossil fuels. So to give you more and a better understanding of the situation, let's talk about a guy. Our guy is called Alex. So Alex is building a cool AI-based application. So what does this AI-based application do? It simply gives you some plans for the tourism. So if you are in Beijing or if you are in Dublin and you are new, you want to know where you can see, when you can hang out, what's the restaurants, what are nice places to walk or see. And this app does all those things. So Alex built is a smart developer working on a tourism app. It uses the AI. Now, Alex has a kind of problem because he doesn't know where he should set or deploy his application. In which data center? Where should that application server be located? Okay, so what are the choices? So let's say he is dubious about running his application, deploying his application on a data center in Montreal, Canada, or in Frankfurt, Germany, or in Dublin. So there are different data centers belonging to one, let's say, cloud provider, and then he wants to know where he should deploy it. Okay, that's a very important question because every time we develop an app, every time we want to deploy it, if we want to kickstart the application, we need to decide, okay, which data center should I put it? And by each data center, I mean, we need to make some decisions about the location. When we want to make a decision, the next thing is, okay, so what are the factors that influence that decision? Obviously, the first one is the latency. If most of my customers are in China, probably it's better to deploy the application in one of Chinese data centers. If most of my customers are in Dublin, obviously Dublin. So one of the key things here is the latency, and that is defined by user proximity. So we want to make our application as close as possible to users. Why? Because we want quick response time. Of course, you're using app, and then you want to get your response as quickly as possible. Even tens of milliseconds matter. So that's one decision factor. The second decision factor is the compliance with the regulations. Okay, so are you allowed to send European customers' data to Montreal? or Beijing or not. And every country or every bloc has its own legal requirements. So that's the second part. The third part is the pricing. So those data centers may offer a cheaper price to attract more developers to deploy their applications on their data centers. They want to fill up the capacity of the data centers, obviously. So these are the three main influential factors. But there's another influential factor that we generally don't look at it, or we really don't take care of it. And that's the environmental impact. Some people say it's just an application. You can deploy it anywhere you want, but we see what happens for the ChatGPT and the huge amount of energy that is consuming. So if those energies is sourced by renewable energy, green energy, it makes a big difference compared to the case where we are using the fossil fuel. So the environmental impact is also very important. To summarize, so these are the decisions that our guy Alex has to take. The carbon intensity, I mean, aside from all those factors and the pricing and so on, the legal compliance, the carbon intensity for Dublin is moderate, Frankfurt is low, and Montreal is very low. And we are going to see why it's very low and how we decide it is very low. What are the influential factors that decides if it's low or not? So now we want to see what is this actually carbon footprint and what is growing. So the AI services and edge computing are very popular, getting more popular than ever. Every software we use, they have a kind of notion of artificial intelligence, machine learning techniques. And in the future architecture, most of the applications will look into the AI to make decisions. And this AI-based applications consume a lot of energy. And then the key thing here is we need to make the choices of where we should put our data needs to be more and significantly smarter. So here is a graph here. It's the energy forecast. So taking a look, the blue one is the networking, like this part. And this is a timeline. So it starts from 2010 to 2030. It's a projection, it's a forecast. And they divide the energy consumption into four different groups. The first one is the network. It can be wireless or wired. Then we have the production of ICT. We have consumer devices, and we have the data centers. And as you see here, two main sectors that is growing very, very rapidly, and the projection is that will grow. One of them is the data centers, and the other one is the networking, both wired and wireless. And the bottom part here, we see three lines. They represent 2015, 2030, and the best case and the expected case. And the blue line is the share of, let's say, networking in the whole energy consumption across all consumers globally. So you see that here the energy consumption for networking will be a bigger portion of global energy consumption. The same for the network for the data center as well. And it's not surprising when you read some news headlines like Ireland's data centers overtake electricity use of urban homes combined. So data centers in Ireland are consuming as much energy as home houses, residential areas. Or data centers accounted for more than a fifth of Ireland's electricity usage last year, like 20% only data centers. And AI to drive 165% increase, like 1.5 times increase in data center power demand by 2023. So the demand for the data centers are growing, and that's very obvious. They are part of the infrastructure for growing, but then they also have the implication of using a lot of energy. Now, there's a very funny question here, is AI a climate solution or a climate problem? Because if AI is using a lot of energy, then it is affecting the climate negatively, but at the same time, we are using AI to predict the climate change or the weather forecast and so on. So it's a kind of dichotomy here. Right, so this is a very brief, not brief, but this is an introduction about the importance of the energy consumption and taking smarter decision toward carbon footprint. The second part of this talk will talk about the carbon efficiency and energy awareness. We covered a little bit in the morning. So I want to drill it down and distinguish and differentiate what are those two terms and why they are different. So energy efficiency means doing more with less power. By doing more, it can be more number of instructions to run on a computer, more number of services, more number of transactions on a service. So that's what energy efficiency means. And it's often measured by operations per watt, transactions per watt, service requests per watt. So it's a unit of computing per watt. And the energy consumption per inference is another measure that we generally use. So when we say energy efficient, it means that we want to run more number of inferences to the AI with a given amount of energy that we have. And take into account some hardware parts, CPUs, GPUs. Some CPUs are more energy efficient, means they use less energy and they compute more. GPUs, neural processing unit, NPUs, they are all part of it, as you see here. So it depends on the hardware configuration. So if you have two servers running 100 inferences, one of them may consume more energy than the other. So one of them is energy efficient and the other one is not. So this is one aspect of it. The other one is the utilization. So let's say we have 5 servers. One of them is running 10%, the other one is running 100%. The one that is running 100% does not necessarily consume 10 times more energy than the 10%. So the energy consumption of the servers are not linear. So they use a huge amount of energy just for the sake of running, even if they don't do anything useful. So that's another factor of the energy consumption. So we really don't want to see underloaded servers. We have some underloaded servers limited for resource provisioning, but in general, we really don't want to see too much of them. And therefore comes to the scheduling algorithm. So we need to schedule the task in a way that we keep the servers busy enough to be energy efficient compared to the ones that are not energy efficient. And here on the top, we have a table about CPU, GPU, and AI specialized, like a neural processing unit, and some figures about how much they cost, how much they save by running them, and what is their energy efficiency. So this is the energy efficiency that we are talking about. As you see here, we don't talk about the sources of energy or carbon or nothing. It's just the energy, how much it consumes to run 1,000 inferences. That's the key thing. Now, let's take a look at the energy. And not all electricity is created equal, unlike human being. So those energies that are created, they have different environmental impact. And here are some of the figures. So let's say each kilowatt hour of coal generates 820 grams of CO2, but then it goes as low as 12 grams per kilowatt hour for the wind energy. So the implication for the environment is very different depending on the source of energy that we are using. And the figure on the right drills down like hydropower, ocean, wind, offshore, onshore, different types of energy. And the reference below also shows if you need to read more about this. So this is the energy source. Then it comes to the carbon awareness. So what is carbon awareness? Carbon awareness means being conscious about when and where electricity is used. So it depends on the location and it depends on the time. Why? Because the energy that we are using based on the source, it is dependent to the location. So let's say we are in South Spain, lots of wind, lots of solar panels, lots of solar energy. It is very different than being in Sweden midwinter. There are no, you cannot expect any solar energy there. But again, if you're, I don't know, in the west coast of UK, you'll have a lot of wind energy. But if you are in another part of the world, maybe you don't have that energy. So it depends on the location first. The second one is about the time. So the difficulty about renewable energy is that you cannot predict them. They are not predictable, accurately predictable. And you cannot expect sun in the night, and some seasons may not be as windy as the other seasons in some countries. So these two factors, when and where, decides the carbon footprint of, or the carbon intensity of the electricity sources. Now, if you want to define what is the carbon intensity formally, it's the amount of CO2 emitted per kilowatt hour of electricity. So if you want to produce 1 kilowatt hour of electricity using specific source, how much CO2 is generated? That's the carbon intensity. Of course, some sources have low carbon intensity, like solar, hydropower, gas, but some of them have higher levels like gas, coal, or more like fossil fuels. And if you want to compare the energy efficiency and the carbon footprint, even if your source code, if your code which is running on the application is super efficient, running very efficiently, but you still use high carbon footprint sources, then you are not doing well. So it's a kind of that's a kind of difference we see in the carbon awareness and the energy efficiency. So the carbon awareness system attempts to shift computing tasks to cleaner times and locations, but the energy efficient one tends to run it on the systems that can run more processing using less energy. So that's the difference between these two. It depends on the time and location. Of course, I talked about it for the carbon intensity. And here's the map. It is generalized for the whole year, so it's not accurate in an hourly basis. It's overall, and it shows the world in 2024. Hopefully 2025 would be prettier. You'll see more light colors than the darker ones. Now, we see the difference between the energy efficiency and carbon footprint. The next question is how we can measure this, how we can measure energy efficiency, how we can measure the carbon impact. So for energy efficiency, there are lots of matrices, of course, but one of the key matrices for energy efficiency is called PUE. It's power usage effectiveness. It measures the effectiveness of the whole facility, the whole data center, the whole rack of servers. And it is calculated as total facility energy divided by IT equipment energy. It looks a little maybe different. So if you have a PUE of 1, it means that all the consumed energy in a data center facility is consumed by IT devices. That's perfect. That's ideal. But it's not always the case, because those data centers, the servers are running, they become hot, we need a cooling system, we need the electricity to light up the building. The IT staff is also using some electricity. So if you add up all those things, then the number will not be one. It would be more than one. So in the real world average is 1.5, like 50% of the energy is consumed for cooling, other stuff than IT computing. And sometimes it's even get worse, like 2 or more. So 1 is the ideal case. That's for the energy consumption, the energy efficiency. The second metric that we can use is like joules per task or per inference. How much energy do we use per single AI inference? That's another metric for calculating the energy efficiency. For the carbon, the metric is different. Generally, we use carbon intensity, and that's the intensity of the electricity used and the carbon emission caused based on that. We can also consume the total emission, but total emission is not something comparable. We want it to be comparable, because the facilities can be smaller or larger. So we generally want to use carbon intensity more than total emission in total. Okay, so we see the energy efficiency, we see the carbon footprint, we know how we can calculate them, how to measure them. The next one is, okay, so how can I do these measurements? I know the formula, I know what does that mean, I know what are the factors involved in that calculation. Now, how can I actually measure that? There are 3 main ways that we can use that. One of them is called Cloud Carbon Calculator. Most of the cloud providers have some features that show you how much carbon footprint your operations cost. So if you have a company, or if you're working in a company and you're running all your services on one of those cloud providers, you can have a dashboard saying how much carbon footprint did your operations cause, generally in terms of days or months. They don't give you detail like hourly basis. It's more high-level report, but you can get that. Google carbon footprint, Microsoft emission impact, and AWS customer carbon footprint. You see the screenshots on the right-hand side. Those are some of the tools that we can use to calculate how much our operations emits energy, carbon footprint. The other one is to use a website called electricitymap.com. It's a very cool website. It gives you an API on an hourly basis. You can query and then ask what is the carbon footprint of energy consumption per location. It gives you the carbon intensity of the electricity for each region, and for each region, not basically your home or your office or your company. It's region based. And of course, by having that, we can choose more cleaner places to run our operations, more cleaner regions. Like when you want to pick a data center, it's better to be among those which use more clean energy. And this API is very helpful. And finally, the last one is you can have your own dashboard. Virtual machines, they have some commands. You can calculate the amount of processing time it is using and then model it, and you have your own customized dashboard to show the energy consumption of your operations, GPU, CPU, and then you can use it to orchestrate your workload in a way that reduces the carbon footprint of the whole system. So to summarize this part, Does energy efficiency means carbon awareness? Energy efficiency talks about the energy only. Carbon efficiency talks about how clean that energy source is. So there's a difference between them. So an efficient app running in a dirty grid still is carbon heavy compared to the other case. Well, we have less energy efficient app, but running on a cleaner data center. So that's the difference between these two. Why data centers have different PUEs in terms of the energy efficiency? If we want to drill down it a little bit, the data centers have different operations. So they have some computing as a main task, thousands or tens of thousands of servers running in a data center using CPU, GPU, storage, networking, you name it. So that's one source of energy consumption on the cloud infrastructure. The second one is the cooling systems that they are using. It's very, very costly. That's the reason why data centers tend to be in cold places like Iceland, or maybe Ireland is attractive for that. So they tend to be more in the areas with lower temperatures, because then the cooling price is lower. The power grid and also network transmission. These are the key sources of the energy consumption. And by doing them efficiently, it helps us to get a better energy efficient data centers. On the right-hand side, you see the percentage of each of those tasks. So cooling is 21%, renewable energy purchase options, and so on. So these are some of the biggest drivers of sustainability gain. Okay, so Alex wants to deploy his application somewhere between Montreal, Dublin, and Frankfurt, but then he realized, oh, he can do something even better. He can use the edge. So instead of deploying them on a cloud data center, it can deploy them on edge servers, which are closer to users. This is a very schematic way of showing it. Like in top layer, we have the cloud. Middle layer, we call it edge servers, fog layer. It depends on the computation paradigm you're working on. So there are there are mobile base stations, macro base station, femtocell, and so on. But there are some edge servers attached to them, and you can run those applications here. The main advantage is that it is very, very close to the end user. So if you are in, let's say in Cork, and the data center is in Dublin, the data does not even have to travel from Cork to Dublin. You can run it as close as the edge server. So the options that he has is cloud computing. The benefit is it's great for heavy computation. The downside is the latency, because the data should go to the core network, congested, delayed, unpredictable round trip time. And the typical energy consumption is 2 times more for higher bandwidth applications. The second option is the edge computing. So in the edge computing, we have low latency. The applications are running very close to the end user. And it's especially critical when we are talking about augmented reality, because we need millisecond scale response time, LLC type of applications. And then that's the decision factors for Alex to decide which one they have to choose. So if they need very tough latency, like AR, VR, autonomous vehicles, edge would be the option. The proximity to user, edge would be the option. But if it's running heavy computation, like training a model, the cloud would be a better choice. Then we have the full continuum from the cloud computing to the edge part. We can have some part of the application running on the cloud, backend part, and more user-faced applications running on the edge part as well. It helps to address both latency and quality of service. Okay, if you want to summarize what Alex should do, the regional selection, time-based scheduling, smart orchestration, and monitoring and feedback are the key practices that we need to take into account to decide where we should put our application to run, whether in Dublin, Montreal, or Frankfurt. The last part, last two slides, is about the government. So the government's also putting pressure towards more carbon neutral and zero emission efforts, all the countries. China, Europe, US, every country is considering that. And in order to do that, they introduce different policies. So the last item that I want to cover is those policies. Generally, we have three types of policies that the governments are pushing, especially for the data center. So if they have, if they consume certain amount of energy, or if they have a certain amount of servers, they need to comply with these rules. So the first one is the carbon credit. So the carbon credit caps and trade system let companies buy and sell emission allowances. So let's say someone is growing forest, it sells the carbon credit to the industries that are producing carbon. So that's the initiative to help reducing or supporting the industries who are capturing the carbon rather than emitting the carbon. The second one is the carbon tax. So carbon taxes are straightforward, emit more, pay more. It's a kind of punishment, not punishment, but it's a kind of de-incentivize people to use more, to emit more carbon. These taxes exist in countries like Sweden, Canada, and pushing the industries towards decarbonization. And the last incentive is the subsidies. So governments also reward green behavior with tax breaks, grants, and so on to promote more eco-friendly industries. So to sum up, as a developer, what we should do, we should look for greener regions for deploying our applications. We need to check the workload and the timing of it to benefit from the places where we have more green energy during specific time of the day. We need to optimize the code to write more energy efficient source codes, energy efficient programs and codes that consumes less. We also need to use cloud carbon tools to understand what is the implication of our operation and try to minimize them. So at the end of the day, our team needs to take into account those metrics as a kind of KPI to measure how our DevOps are performing. And this is the conclusion slide. So energy is not equal to clean. Location matters. Smart decisions, lower emissions. We have tools, we need to use it, and also we need to be aware of the government policies. Thank you very much. Any questions?